Okay, what happens to our Limacons graphs when we change from sine to cosine? Well, let's take a look at a cosine graph. Cosine graph has different key points, of course, than a sine graph does. At 0 degrees, we are at 1. So the highest value for cosine would be 1 at 0 degrees. And again, of course, we'd be back there at pi over 2. Our other key points occur at right here, here, and here, so I'll add those in. At pi over 2, and at 3 pi over 2, cosine is equal to 0, and at pi, cosine is equal to negative 1. So putting those values into our equation, when we put 0 in for cosine, we have 4 plus 4 times 1, because cosine of 0 is 1. So that would be 8. So we're going to get our maximum value at the angle 0 instead of at the angle pi over 2. Of course, that would be the same thing if we go all the way around to 2 pi. We would be back to where we started from, and the graph would start over again. The minimum value would be 4 plus 4 times 0, and that's when we put in negative 1. I'm sorry, 4 plus 4 times negative 1. If cosine of pi is negative 1, we would have 4 minus 4, which is 0, right here. So that would be a point right on the pole. Then when we have the angle pi over 2 or 3 pi over 2, cosine would equal 0, so we would have 4 plus 4 times 0, or 4. So notice where cosine equals 0, which is pi over 2 and 3 pi over 2, then the radius just equals this first number a. So 1, 2, 3, 4 up, 1, 2, 3, 4 down. Now, a couple of key points that would be helpful for cosine would be to find another nice angle. The nice angle for cosine is at 60 degrees, because 60 degrees we have the 1, 2, square root of 3, 30, 60, 90 triangle. So now we have adjacent over hypotenuse is equal to 1/2. So cosine of 60 is equal to 1/2, which means we'd be looking at cosine of pi over 3 equaling 1/2. So if I put pi over 3 in here, cosine would equal 1/2. I would have 4 plus 4 times 1/2, which is 6. So at pi over 3, I would have a radius of 6. Now, using symmetry, remember cosine is symmetric with the horizontal axis. My other place where cosine is positive would be 5 pi over 3 down here. So this would be another point, and I would have a cardioid, but sideways now. So it just touches at the pole, goes around like this. And it's probably not quite so pointy there. Okay, more rounded at the top, more rounded. I don't need to be quite so picky, I guess. But I just, like to draw pretty graphs. All right, now I'm going to skip over number 2 and leave that to you for homework. But I want to do C, and I don't know if you have if I change this on the worksheet. Hopefully I did already. I changed this on the notes, but I want to do one where r is 3 minus 7 cosine theta, because I want you to see what happens when we make something negative in the equation, how that affects the graph and the points that you're plotting. So once again, just looking at my cosine graph, it starts up high. Cosine of 0 is 1. If I put 1 into the equation for cosine of theta, I would have 3 minus 7 times 1. I would get negative 4. So when the angle is 0, my radius is negative 4, which is the opposite direction from 0. 1, 2, 3. So that's why I wanted to do this. 1, 2, 3, 4. There we go, right there. Now when I put pi over 2 in, then it gives me a cosine value of 0. 3 minus 7 times 0 is 3. And that's also going to happen at 3 pi over 2. So at 3 pi over 2 and at pi over 2, my radius is 3. Now when I put pi in, cosine of pi is negative 1. So I have 3 minus 7 times negative 1, which gives me a positive 10. So at the angle pi, the radius is 10, which would be right out here. So notice we have 2 points on the same side of the pole, or the center of there. That means there's a loop. That means this one's going to make a loop. So it's going to be an outer one with a loop in the middle. Now looking at my special values for, and then of course this is just back to where I started from. Looking at my special values for cosine, I'm not really as interested in what happens over here at pi over 3 and 5 pi over 3. I'd much rather see what happens at 2 pi over 3 and 4 pi over 3, because that's where the bulk of the graph's going to be. So cosine of 2 pi over 3 is actually equal to negative 1 or negative 1/2 rather than positive 1/2. So if I put in the 3 minus 7 times negative 1/2, I would get 3 plus 3.5 or 6.5. So at 2 pi over 3, I would be at 6.5, and then I would, by symmetry, you could also see that would also be true at 4 pi over 3. So now when I draw this, I have an outer round limacon with an inner loop. And there we go. The rest of, I think that's enough examples for you to see kind of now what we're looking at with these graphs. If I were to graph this one using y equals, I'll just do one more of these, 3 minus 7 cosine of theta. This is one where my sinusoidal axis is 3 and my amplitude is 7, but because it's negative 7, it's actually an upside down cosine. I don't know if you remember doing those. That's been a while. Okay, so 3 minus 7, amplitude is 3. So, or sorry, sinusoidal axis is 3. 1, 2, 3. Amplitude is 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. So it's going to go down to negative 4, 3 in the middle, and up to 7, or up to 10, sorry. 3 plus 7 is 10. But if I put in 0, okay, when I put in 0 degrees, I'm going to get 3 minus 7 times 1. Okay, so cosine of 0 is 1. So I'm going to be down at negative 4 as my starting value. And I'm going to end at negative 4. In the middle, I'm going to be up at 10, and then I'm going to be on my sinusoidal axis halfway through. So this is actually what this graph looks like. Okay, so notice where this loop is occurring is actually, the loop is occurring at pi. It's sort of an upside down graph. This is kind of weird because if you look at the different radius, I have a radius of negative 4, then I have a radius of 3, then I have a radius of 10, then I have a radius of 3, and then I have a radius of negative 4. So it's exactly these radiuses here that are the same as the y values on this graph. So just to show you what it would look like. It's kind of interesting. The rest of these the worksheet is for homework, and we will talk about some of the other features of these then as we go over the worksheet tomorrow.